Okay, so this says graph the following triangles after a dilation with a scale of 4/5. So somebody remind me, what do I need to do here? We're trying to find this new triangle. Is it going to be larger or smaller? Smaller, because the fraction is less than 1, because the numerator is smaller. So how do I find where all those new points are?
You take the points there on right already, so like 0, 0, 2, 0, 10, 0,
10, 0, and awesome. So we're going to multiply all of those by 4/5. So the x and the y each time. So my new triangle, well, 0 times anything is 0, so this one's easy. So that one stays the same. Now, so let's see. 10 times 4/5. Multiply across and then reduce. So that's 8. Do you guys know you can also do fractions on the calculator? Have I showed you that yet?
You showed me, not them.
Okay, let's do this, because this might help with this. I don't want you to get something wrong because fractions are not your friend. So let's see. Here we have, let me turn it on, 10 times, right, 4/5. So you see this key right here? You see this key? Hit that. No, back up.
I think it's the one in there.
So 4/5. You're going to go 4, the fraction key, and 5. So that makes it that little, like, kind of, I don't know, what do you call it, a little corner thing here, is really like the calculator's representation of a fraction bar. So this means 10 times 4/5. Hit equals, and you get what it is.
Oh, I just divided I just turned the fraction.
Okay, so you could also do exactly what Jason said, and it was what, 4/5? 4 divided by 5 is 0.8. Multiply that by 10, and you get 8. Either way, use your tools, right, when you can. So this one is 8, 0, multiplying 10. So what about the next one? I have to multiply -5 by 4/5. What do you get? -4. I mean, this one you almost don't even need a calculator. The 5s cancel, and a negative times a positive is. Okay, so plot those points now. So I'm 0, 0, 8, 0, -4. There you go. It's the same shape. It's just that it's been shrunk. And these would be similar. And that 4/5, they call it the scale factor here. It's also called the similarity ratio. And it's the side of the first triangle over the side of the second triangle. Or the second one over the first one, because we're going smaller. Okay? Okay, let's look at the next one. This is where we have a little bit of stuff that's new. But first thing we need to do is graph the following dilation with a scale factor of 4/3. So now is this one going to grow or shrink? It's going to grow because this is 4/3 is really like 1 1/3, right? So it's going to grow bigger. So I'm going to put this on pause. You go ahead and find those numbers and grow this rectangle. So here is what your points should be in the new rectangle. The next thing it asks us to do is find the perimeter and the area, which there is the work for the first one. We're getting ready to do the second one. Okay, so remind me, what do I do to find the perimeter? Add them all up. So here my perimeter is what?
24.
And my area was length times width. So it's 8 times 4, which is 32.
33.
Okay. So the next question here, it says, are the rectangles similar? So it's a yes or no question. But it's not a 50-50 guessing. I want to see the work that's proving it or backing it up. So there's, I'm kind of going to put this over here. So we're going to prove similarity. So we can do that different ways. So we can do it by the sides. Looking at the sides from the first one to the sides from the second one. So like long side to the long side. 6 to 8 equals short side to short side. 3 to 4. Cross multiply these, and if they're equal, then that means it's similar. And it is, right? 6 times 4 is 24, 8 times 3 is 24. Okay. We could also do it using the perimeter. So to do the perimeter, we're going to take the sides, a ratio of the sides equal to a ratio of the perimeters. So let's just use the same thing here, the 6 over 8. So that was the sides of the smaller one to the sides of the larger one. And then I can do that with the perimeter. The perimeter of the smaller one to the perimeter of the larger one. What do you get when you cross multiply those? Well, what is it? 6 times 24 is 144. 8 times 18 is 144. Oh, it's showing that it is also, right? We could also show it by the area. So, taking a ratio of the sides, it doesn't matter which sides we pick. Let's use the small ones this time. The shorter sides to the ratio of the areas. Now, is that how I do it with the area? Or do I need to do something a little different? Remember, this is area. Yes. So the sides have to be squared when you're comparing area. So this would actually have to be 9 over 16 equals 18 over 32. And let's see if that works. What is it when we multiply there? 9 times 32? do 88, is that what I heard? And then 16 times 18 is 288. So basically, those are three different ways to show that yes, it is similar. You only need to use one of them. You know, and if I don't tell you which one to use, you can use whichever one you want. Okay, but maybe I'll tell you, use the area to show that they're similar. Then you have to use the area. Maybe I'll tell you, you have to use the perimeter. Then you have to use the perimeter. Right? Does that make sense? Okay, any questions? Okay, I'm done. You have an assignment to